All right. Is everyone here?
Yes, ma'am.
Okay. Have you noted down the reaction before we get it? Okay. All right. So this is silver mirror test. Just a visual. It's a transparent solution, but if the test is positive, like it shows positive for silver, like with aldehydes, so you have the silver being formed here. Oh wow, this is like a lot of silver mirror. Okay. All right. Back to this. So that was tolerance test. The next one, this is also an oxidation reaction. So this is called Felix test. So Felix test, you make Felix reagent. Like first, you need to prepare two solutions. So there's Felic A.
Spelling A and B solutions.
Yes. What is Felic A solution? Do you remember?
Was it something related to ferric or ferrous, something like that?
This is aqueous. Yeah. So Felic A is aqueous copper sulfate, and Felic
Spelling B was something
yes,
tartarate or something.
potassium tartrate. Yes. So this is also called Rochelle salt.
Salt, yeah.
So these two you have to, again, just like tolerance, you have to prepare Felling A and Felling B freshly. And then before the reaction, you need to mix Felling A and B in 1:1 ratio, equal quantities of Felling A and B. So this is just before the test. Then when you add the aldehyde in the Felling's reagent ka solution, this is the reaction that will take place. So if it is an aldehyde, that will get oxidized to acid. So once you mix this, you're going to have copper ions in the solution. You have Cu2 plus, and you're doing it in an alkaline medium. So you have lots of hydroxide ion, 5OH minus. This is going to oxidize your aldehyde into carboxylic acid, RCOO minus. And copper itself is reduced from Cu2 plus to Cu plus. So you end up getting CuO and 3H2O. This is for medium balancing. Do you remember what does this look like? What is the test? If Felling's test is positive, what are you looking for?
Remember?
You don't remember it? Okay. Do you know what is the color of Cu2 plus ions?
Blue color.
Yeah. So
Yeah.
start with you mix in a blue color solution, and when copper is reduced, when you have Cu plus, this is a red brown precipitate. Okay, so this is the identifying factor for Felling's test. So tolerance made transparent, say you're getting a silver mirror. Felling's test, if it's positive, if this reaction has taken place, you're supposed to get a red-brown precipitate. So ketones don't give this. Another thing with Felling's test is aromatic aldehydes also don't respond to this test. So only alkyl group ka aldehydes, only aliphatic aldehydes will give this particular test. Okay, let's finish writing. Let me see Fleming's test. So you're going to have like tartrate and all also will be in the solution, but the main reaction that oxidizes the aldehyde is the copper ions present in this. So copper gets reduced to Cu plus and aldehyde is oxidized to carboxylic acid. It's the main thing. Yes, let me know when you finish noting down the equation. Yeah, this is what it is. This image. There you go. So you use tolerance tests, like a lot of these tests are used in again identifying what functional groups are there, right? So they played a very big role in figuring out the structure of glucose, the structure of sugars. They knew that okay, C6H12O6 hai uska formula, but like are they all hydroxy groups or do you have like any sort of unsaturation present? All of that stuff. So glucose and fructose showed positive for Fleming's test, but this other sugar did not. This is the identifier. Okay. There you go. So Cu2 plus is blue, Cu plus is red. So in Fleming solution also is the same thing. That okay. Right. We look at the next equation.
Could you show the previous one?
Huh.
Yeah, okay.
All right. The next one. So it's the fourth oxidation reaction, but the third test. This is called haloform reaction. Specifically, when we're talking about haloform, matlab halogens, specifically when we use iodoform, it becomes a test because that has a characteristic color to it. So the general reaction is this. So you take any. So this particular test is not for figuring out, aldehydes, ketones, like the functional group in general. This is for detecting specifically if you have an acetyl, basically an acetyl group. So if we have CH3, C double bond O, and then R, could be hydrogen, could be like any group. But basically, if this particular group is present, CH3 and C double bond O, this on reaction with sodium hypohalite, so that's NaOX. So this is called sodium hypohalite. So hypochlorite, hypobromite, hypoiodite. That's the name of this salt. This is converted to the particular methyl group attached to C double bond O is oxidized into ONA. And so that is converted to a halo form, like whatever halogen you take over here, that particular. So you get CHX3. Again, goes without saying X equal to Cl, Br, or I. You don't do this with fluorine. Okay, so why this is one of the tests, because when we are specifically when we specifically use NaOI, sodium hypoiodide, so you end up getting iodoform. So iodoform gives, so this is a bright yellow compound. So this is used to test the presence of CH3CO group. So as a test, you get it as a bright yellow precipitate. Okay. Have you guys done this one in the lab, iodoform test? Or was it only
Yeah, the yellow precipitate one we have.
you did? Okay.
Yeah, we've done this.
Huh. Yeah, because you're starting off with a sodium salt, here also you end up getting a sodium carboxylate and the haloform. Yeah, so if you take a chloride, you had hypochlorite, you get chloroform. You take hypoiodide, you get iodoform. That's why this is called the iodoform test. So another thing, iodoform like used to test for the presence of acetyl group. You can also use it to test the presence of CH3 CHOH also. The reason why it's useful for this also is because this gives this particular group on oxidation. So either of them. Let's write it clearly. This also because it gives CH3 C double bond O on oxidation. So again, this is also an oxidation reaction. So it's like one more step. So this on oxidation gives this, and then this can be oxidized into carboxylate group and gives the iodoform as an end product. So both these groups can be tested with iodoform. So this is the important thing you need to remember, because again, in a question, if you come across, oh, this is positive for iodoform test, or it gives a bright yellow compound with iodoform test, or with sodium hypoiodide, then you need to, like, that's a hint for you that, okay, final structure may, it has this particular group. May and finish. All right. Test done. Smira, Kaveri, Sia.
Yes.
Okay,
Yeah.
cool. The next reaction. So that's it for oxidation. Next one, we'll be talking about the alpha hydrogens. So mainly there's only like one or two sets of reactions, aldol condensation and cross aldol condensation. Okay. So what is the alpha hydrogen in this in like, okay, so if you have any aldehyde or a ketone, so there's C double bond O. So the first carbon that is attached directly to the C double bond O is the alpha carbon. And if this has a hydrogen bonded to it, so this particular hydrogen is called the alpha hydrogen. So this is what we'll be focusing on. So there's a special property with this hydrogen. So this particular hydrogen, so alpha hydrogen, is acidic in nature. Matlab aldehydes and ketones are capable of uh, releasing this hydrogen as H plus ions. Okay, can you figure out why? Any idea why?
Because why is the hydrogen acidic? That's what you answered.
Yeah, like how
Because
can
it can be easily lost.
easily
That's
lost
why.
as H plus. So how is that?
Yeah. Hyperconjugation.
uh, sort of. It's more due to again the
Is
electronegative
it like
effect.
yeah?
This thing, yeah.
So it, because I don't is there will there be resonance here? No.
We don't call it resonance, but yeah, it's because of electronic
That's
effects only. Yeah.
That is hyperconjugation only, na? Ki like the more number of H atoms there are.
Yeah, so when you have a like hyperconjugation, yeah, you have it when you have alternating sp3 and sp2
Yeah,
carbons.
right.
Yeah, so the hydrogens attached to sp3. Yeah, so very similar, like basically that's what happens here. So oxygen pulls on these electrons because it's electronegative. Then carbon has a slight positive charge, so carbon tries to attract the electrons from around it. So if it pulls on these electrons over here, it becomes easy for this hydrogen to be lost as H plus ion. So in the presence of any base, like suppose I have any random base with its extra electrons here, it's easy for this base to take this hydrogen. So essentially what happens is, like, how is this acidic is basically you get this sort of an intermediate. So you have the base attacks this hydrogen. So you have C double bond O. There's this carbon here. And this gets a negative charge because H plus is lost. So yeah, oxygen takes these electrons migrate over here. So you're back to that like it is stabilized by that ketoenol tautomerization thing. So you end up getting C, single bond O, and this becomes double bond. So because these electrons are capable of moving between these three atoms, like if this hydrogen is lost, there is these electrons migrating between these three atoms. So because of that delocalization, the anion becomes stable, which is why it's okay for the aldehyde or ketone to lose the alpha hydrogen. Okay. So this resonance that is established in the anion, like the conjugate base that is formed, so this stabilizes the conjugate base. And so the alpha hydrogen is acidic. So the more stable a conjugate base is, it'll like to form that uska conjugate base. When we're talking about conjugate base, uh, due to the laws of H plus means that's acidic nature. Okay, so remember this mechanism, the fact like how the electrons are moving, where do you have the positive charge, where do you have the negative charge, because we'll be using that for the set of reactions. First, we look at aldol condensation. So aldol condensation is these reactions take place between two different molecules of aldehydes or ketones. If it takes place between an aldehyde and a ketone, like two different molecules, you end up calling it cross aldol condensation. Okay, so so the general like funda of this reaction is, so if you have aldehydes with a like if you have aldehydes or ketones with at least one alpha hydrogen. So this reaction will take place only in the aldehydes or ketones with alpha hydrogen. If this hydrogen is not there, you will not have this reaction taking place. So then in the presence of dilute alkali like NaOH or KOH, the products that are formed are, you have beta hydroxyaldehyde, so also called aldols. And suppose we talk like if you do it with ketone, you end up getting beta hydroxy ketones, also called ketones. Okay. Pretty easy, like you can see it from the name. So you still have the aldehyde retained, just that on the beta carbon, you have a hydroxy group attached. So how you end up getting this is through this reaction aldol condensation.
So like for ketone with one alpha hydrogen we'll get aldol, and for sorry, for aldehydes with one alpha hydrogen we'll get aldol.
Yeah. It's just the name difference to show the difference in the structures, but otherwise the mechanism and all will be the same. So I'll take an example and we'll do one reaction of aldol condensation. So this is important.
Ma'am,
Yeah.
when will this recording be uploaded? Is it possible to upload it by today?
Yeah, it'll take some time, say like by 8 or 9 o'clock by the time all.
Yeah, that's okay. But I was planning to study this tonight, so I might need it.
Yeah, ठीक है.
Okay, alright, thank you.
Alright. यहाँ तक लिख लिया. Should we look at a reaction now? Sia?
Yes, ma'am.
Okay. Sia, what about you?
Yes.
Okay. So, simplest aldehyde लेते हैं. So, suppose we take 2CH3CHO, acetaldehyde. Okay. In the presence of dilute NaOH, like if you make it react with a dilute alkali, so let's take dilute NaOH. What happens is, so I'll break it down here. So you have CH3, or let's write, we need the alpha hydrogen. So C double bond O, H, H plus CH3, C double bond O, H. So two molecules of an aldehyde. So because the alpha hydrogen is acidic, if you remember what we have noted down over here, what happens is, if this gets lost as H plus, so this bond breaks, so this is lost as H plus, then these electrons migrate over here and this electron migrates over here. Now, if you look at this other thing, you have the nucleophilic addition mechanism taking place. So this has a slight positive charge. This has a slight negative charge. So if you have this lost as H plus, there is negative charge on this particular carbon, right? One of the forms. So let's not look at the resonating forms. If this is lost as H plus, this carbon gets the negative charge. Guys, you following?
Yeah.
Yeah. So this negative charge is attracted by the positive charge on the carbon. So there is a bond between the beta carbon of one aldehyde and this carbon of the other aldehyde. So the structure you end up getting kind of looks like this. So you have CH3, C double bond O, H, this remains. Acha, addition reaction hai na? So this double bond turns into a single bond. So this particular hydrogen attaches itself to this oxygen. So this becomes OH. And yahan pe I have CH2 and C double bond OH. Okay. So if you look at the structure, you have beta carbon pe hydroxy group and you have an aldehyde group. So this is a beta hydroxy aldehyde. Other words, an aldol. And you can see the name aldol comes from ald for aldehyde and all because it's got the alcohol group. It's a mix of both of those names. So aldols are important because when you heat aldols, it loses a molecule of water to give an unsaturated product. So it loses water like OH from here and
So,
from here.
but like every time there is a aldol condensation. Okay. So we have to write the water wala step, no?
Yes. So this is the condensation. Like pehle aldol is formed and then water is removed from that. That's condensation. So
So then, like the condensed compound is not the aldol anymore, right?
no.
What is it called? It doesn't have a particular name.
It's just you have double bond and like you can figure out the
Aldehyde.
IUPAC name, but otherwise,
Yeah.
so you just call it the aldol condensation product. Condensation के बाद जो भी product है, that's why aldol condensation product. Okay. So suppose you're asked what is the final, like if you're asked to give the reaction mechanism and all, you write the whole reaction. But if you're asked what is the final, suppose MCQ question जैसा कुछ है, what is the final aldol condensation product means, you need to mention the compound with the double bond in the structure, like condensation के बाद after the water molecule is eliminated.
So like this particular aldol will have the name 123 propan, something like that, or
Okay. Bute. So you have
not this one, the aldol, yeah.
aldol will still be bute, no? So this will be
Yeah, sorry, 4, yeah.
yeah. So beta hydroxy butanol. If you want to figure out the IUPAC name, it's going to be hydroxy. This will always be first carbon. So 3 hydroxy butanol. You'll always like aldols will always be 3 hydroxy because the OH is always formed on the beta carbon. Okay. So for practice, tell me what you get from ketone, acetone, CH3COCH3. If I take 2 CH3COCH3, heating it with dilute NaOH. So give the structure of ketol that you get from this and also the aldol condensation product. So on heating, when it loses water, what product do you get? Or let's call it क्योंकि ketol से आ रहा है, ketol condensation product.
How do we write it like on chat?
Have you written it in your book?
Yes.
So just write it left to right and जहाँ पे भी there's branching, put it in brackets.
Okay.
Guys, this is a
For
whiteboard.
this,
Yeah. Tell me.
you will write the double bond of the O. So there'll be 2 double bonds. One for no, there's no CHO in this, right? So there'll be CH3CO double bond, CH3, then
CH3, like these two CH, in one of the molecules, the 2 CH3s will remain as it is.
one of the means there are 2.
Huh? So 2 molecules of acetone we are taking, right? So aldol,
Oh,
Kaveri, let me cross check. So we have, yeah, Kaveri got it. That is correct. Yeah. So what is the final ketol condensation product? Can you figure that out? Like, can you just put that also in send?
Ma'am, is mine correct?
Yes, ketol is correct.
Yeah.
So an easy way to figure this is, one will remain as it is. So you have C, C double bond O, C. ऐसे ही रहेगा. The other one is going to have this nucleophile thing, like the single bond will be converted to double bond. So that is attached to the like ये वाला, like double bond के बाद जो भी है, the alpha carbon. So यहाँ पे you end up getting C, इसका OH होगा, and then the other two will remain as it is. CH3 will remain as it is.
I don't understand how we'll get, like, know how many carbons will be there. Like,
Huh. If you want,
Like
you
only
can like break
this
it
one
down
has-
side may. See. So I have CH3, C double bond O, CH3 plus
yeah.
CH3, C double bond O, CH3, right? Aldol
Yeah.
condensation, matlab, obviously, like if you look at aldol condensation, means that you have to deal with alpha hydrogen. So let's say इस molecule का एक alpha hydrogen निकाल रहे हैं. So this becomes CH2. Then इस molecule का this double bond turns into a single, and this has negative, this has positive. So if this goes and joins over here, so because this molecule is remaining as it is, the only change is that it's losing one alpha hydrogen. That's it. So let me start with that. I'll write CH2, C double bond O, CH3. So if this is losing an alpha hydrogen, what is coming in the place of that hydrogen? Is the second molecule ka carbon. So this is bonded to carbon. I've taken account of this. Aldols, ketols, matlab beta hydroxy. So this becomes, there is an OH here. So this is also done. Now this carbon is attached to two other CH3s. So I'll just write with it. Okay, go step by step. Make sure that you have, okay, 3 carbons.
One of the alpha carbon which is eliminated.
Carbon is not eliminated. Hydrogen is eliminated.
Sorry, one of the hydrogen which is eliminated from the CH3, it goes and forms OH with the O of the second molecule.
Huh.
And to the first compound, like the carbon